Hello everyone, welcome back to the next lecture in Computer Network series. And today we will see the basis of Cisco Packet Tracer Part 2. In Part 2, we will be mainly focusing on hubs. We will see the outcome of today's session. In today's session, we are going to know the basis of Cisco Packet Tracer, know about hubs, stimulate local area network using hubs. Finally, we will understand the pro and con of hubs. Hub. It is also known as a network hub. Hub work at the physical layer of the OSI model, used to set up LAN or local area network. Hubs has multiple ports. Within our practical, we'll be using start topology network or start topology to build our first local area network. When a packet arrives at one port, it copies to all others to the port, so all the segments of the local area network can see our packet. This is the drawback of hubs. So within a 16 port, if a packet arrives at port 1, it will broadcast the data to all other 15 ports. So what it do, it will copy the data and then it won't open the data. For the main packet or the main port, if it's port 15 will receive the data from port 1 to port 15. So within our practical session, we'll use start topology to build our network, our local area network in our practical session. Okay, within our practical, we are going to build a local area network to connect 6 devices. And this is start topology, local area network we're about to build. So now we take one central hub. There's a hub. Yeah, there's the devices. Now this is 6 devices. We will connect 6 devices to the central hub. Now there's a connection. Within our local area network, we'll use the straight through cable. Now there's a cable. You have to connect to fast Ethernet. Okay, now this is central hub, and the central hub has 1, 2, 3, 4, 5, 6. 6 computers connected to the central hub. So what the central hub will do, it will broadcast the data to all the devices. And then the main device will receive the data, will open it. So this is how the hub works. That is the drawback of hub. Hub receive the data and send the packet to all the devices, but they won't open it. But the main data I have the SOMAC MAC address, and the recipient or the receiver will have its own header and tether, which is the sender will attach a header to it. So any device, all the devices will receive, but the particular data I got, the SOMAC MAC address or the same IP, the SOMAC address of the device sent, it will receive. This is a drawback or how hub work. So within our practical session now, we have to give each of these device an IP address. So you have to click on the device, you come to desktop, IP configuration, give an IP address. Desktop, IP config, come to each of the devices you have to get a unique IP address. Now the first device will give 10.10.10.1. So the second device will get 10.10.2. This is how you give an IP address to devices connected with the same connected to the same hub or the central switch. Okay, so now all the devices have its own IP address, a unique IP address. So we have to come to the central hub and then see how many ports on the central hub and where the devices have been connected. So you click on the hub. Now this is 6 ports and each device has its own port number connected to the hub. So every port has its own device connected to with an IP address. This is how the physical device or the hub, the central hub work. So we have to put the central hub on, and then this is a switch. This is switch. So now the hub is on. This is how you see the green light. Each device 1, 2, 3, 4, 5, 6, and this hub has 6 ports. So each device is connected to one of these ports and have its own IP address. In our next practical session, we'll discuss each of the ports with a SOMAC MAC address, and we'll see the drawback hub and switches. We'll see the difference between switch and hub. We'll see how hub work and how switch work. So in this session, we will see how packet leave from one destination, travel through hub, and hub will broadcast the data. Hub will broadcast the data to each devices, but the main device will receive the data and it will open the packet. So the nose, this is the nose, or you call it the straight through cable in the central hub. So let's take a packet from here, packet 1, and we'll take this packet from PC3 to PC15 to see if this packet are connected. You come to this PC, you click on the PC. What you do, you come to command prompt, put in rpconfig, and press enter. Now this device is device 6. This is why you see the IP address with the SOMA MAC address. And we have to put in rpconfig. Now recently you see this device telling say in command prompt we use rpconfig. So say rpconfig $10 enter. Now we keep getting invalid packet. So you can go on this rpconfig. Now this device has rpconfig. We use rpconfig to get the network configuration and to see the IP address, while the IP address is unique. So now each device here has its own IP address. So we'll take another packet, So this packet will already send packet from here to PC5. So real time will see if our data that is coming or the data have been sent is going directly to the receiver. Real-time stimulation. Now this is how help work. Help receive the data and send the data to all the packets or all the devices. So this device 5 receive the packet and then send the packet back to the help. Help broadcast the packet. And they did not open the packet and the packet went directly to PC3. This is how help work. And the drawback is that it will broadcast the data to all the devices that are connected to the help. But they won't open it because they are not a receiver with the data. The data travel with header and tether. In our next discussion, we'll discuss the header and tether, how it does work. So come back, real time, and see successful. So PC3 can communicate with PC5. Now this is PC3, the source and the destination. Now the source and destination mean the source can send data to the destination will receive. This is why you see line status is successful. Real-time stimulation. Okay. So PC5 receive the data and then these other PCs receive but did not open the data. Now this is how help work. PC5 send the data back to PC3. Okay. So let's get another one and you will see how easy help work. So take this packet, the one packet from here to PC. So PC1 taking packet from here, send to PC4. What PC1 will do, PC1 will send the data to the hub. So the hub will broadcast all this data and then the main destination will receive. Now PC1 and PC4, PC1 is the source, PC4 is the destination. So here they are successful. It means PC1 can communicate with PC4 real time stimulation. This happens because there are many packets that have been sent. So PC3 sending packet and PC1 sending packet so that they help somehow confused. But we see again, this is how the help work. So because the help doesn't know which packet or which devices, because two devices sending fail. So let's take this packet from here. Let's come back. Config PC4. PC0 has sent the packet to the help. So the help will broadcast the data. So the remaining two did not receive the packet. They received but they did not open the packet. So PC4 send the data back. They received but they did not open the packet. So PC4 send the data back to the help broadcast. So PC0 has received the packet. So guys, this is how help work. In our next practical session, we'll see the function of switches. We'll see the difference between switch and help. We'll see the difference between IPv4 and IPv6. So guys, keep watching my YouTube videos. Like and subscribe. The more you like, the more you subscribe, the more I feel impressed to make new content. Thanks for watching my video.